Hello people and welcome to this video. In this video we will learn how to create a personal security camera using Python. And the library that we are going to use is going to be Opencv. So first let's just install it. We will open the command line and then we will write pip install python opencv. And as I have already installed it, it's going to say something like requirement already satisfied. So now we can finally move to coding. This tutorial is going to be very easy and very simple. We will create the security camera in just 30 lines. So let's begin. So the first thing we need to do is of course create a file. Now we will be importing Opencv. So first thing is we need to install it in our system. And we are using Opencv because it is mainly created for computer vision and stuff. So now we will import it just by writing import cv2. Now after that we have imported it, we need to create a camera, an object that will capture the video from your camera. So we will simply do it by just writing camera equals cv2.video capture, and in parentheses we will specify the camera we will use. So it is just by indexing in Python that starts from 0. So I have only one camera in my laptop, so I will put 0 in it. If you have more than one and you want to use some other camera, like it is your second camera, so you can just index it that way. Now we will create a loop that will create a screen for our video. So we will do it simply just by writing while camera dot is open. And so it is just a simple English, so you can understand is opened. It checks if the camera is opened or not. And if it is open, then just execute the loop. So now we will gather the data from our camera. So we will write r comma frame equals camera dot read. And what it will do, it will just send the frame that is being captured by the camera to the frame variable, and the r variable is just for the object that is being returned from that camera dot read, and we don't actually need that object, we only need the frame, so it is just kind of waste. We don't need to worry about it. Now we will write cv2.imshow, and in parentheses the first thing we need to pass is the title that we want on the window of our video, and the second thing will be the frame that we want to show. So we will write security camera as the title of the window, and then we will write frame because our video is being captured and sent inside the frame variable. So now we don't have anything to close our window, so we will create something like an if statement that will break the loop, because if it won't break the loop, our video screen will remain on our window, so we don't want that. So inside the loop we will write an if statement, if cv2 dot wait key, and then in parentheses we will specify the time that we want the wait key to be. So we will set it as 10 milliseconds, and then we will check if it is equals, or if the key that has been pressed is q or not. If it is q, then break the loop. So now that we have done it, we will now run the program. So now it is working fine. Now we will work on the logic that will help us to create this simple camera into a security camera. So now to detect if something is happening on our screen or not, what we will do is we will compare the before image and then the after image, and if there is difference, we will highlight it. So we need to create another frame to compare our previous frame with. So just like we created our previous frame, we will write the same command for another frame. We will write r comma new frame equals camera dot read, and now we will check the difference between these two frames. So CV2 makes it just very easy. So we will write difference equals CV2 dot absolute difference, which is ABS DIFF. And then in parentheses, we will specify the two frames that we want to find the difference of. And now, instead of frame inside the cv2.imshow, we will write difference. Now let's try to run it. Now as you can see, everything is black and white here, but if I move something or if I move my body, it shows color. So now as you can see, it's definitely gonna help us in differentiating if anything is happening in our room or not. But to make it easier for the computer to understand, we will change the color of the frame into gray. So what it will do, if something changes, instead of showing colors, it will show the white color. And if something does not move, it's just gonna show black color. So to do this, we will write the command gray equals cv2.cvt color, and then in the parentheses we will write the name of the frame that we want to turn gray. So we will write difference because it is what we want to turn into gray. Now we will put comma and then we will write cv2 dot color underscore RGB to gray, and then we will close the parentheses. And now let's, instead of writing difference in the IM show, we will write gray and then we will run it. As you can see, my video is now turned out to be gray. Now we will blur our gray video. We do this to make the color transition from one side of the image to another side with the edge to be smooth rather than sudden. So to do this, we will write blur equals cv2 dot Gaussian blur, and then in parentheses we will write the source frame, which is gray, and then we will write the kernel size, which is 5 by 5, and now we will set sigma x to be 0. Now we will replace gray in IM show with blur, and now we will run it. As you can see, my video is blurred now. Now we will do some threshold in our frame. What it will do, it will just sharpen the image. So we will write underscore comma threshold. We don't care about underscore, it is just to keep the another object that is returned by the following command, and then we will write equals cv2 dot threshold, and then in bracket we will write blur because it is the frame that we want to set the threshold in, and then we will write the threshold value, which is 20, and then we will write the maximum threshold value, which is 255. And now we will specify the type of threshold that we want. So we will write cv2 dot thresh binary. And now we will run it. Now as you can see, the black part are complete black and the white parts are completely white. So it is just helping us to detect even the smallest changes that is happening on our screen. Now we will dilate the threshold object. So why are we doing this? To make the white parts in our video much more significant. So we will write dilate equals cv2 dot dilated, and then as the first parameter we will pass threshold as our source frame, and then we will set the kernel, which is none, and then we have to set the iterations. So we will set the iterations equals 3. Now it's time to make the contours in our video screen. We will write contours comma underscore, and underscore it's just a waste, don't care about it. And then we will write equals cv2 dot find contours, and then as the first parameter we have to pass the image, that is dilate. Then we will set the mode, we will set it to be retr underscore tree. We will write cv2 dot retr underscore tree, and then we will write the method that we want to use to find the contours in our image. So we will set it as cv2 dot chain approx simple. Now let's just draw the contours and check if it is working or not. What we will do, we will write cv2 dot draw contours, and then we will pass the frames in which we want to draw the contours. So it is going to be our original frame, and we will also change it in the IM show. We will set it as frame, and then we will write comma contours comma -1, and then the color of the contour that we want. For this video I am doing it blue, and then comma, we will specify the thickness of the contours. I will set it as 2. So now let's run the program. As you were able to see, every movement that was happening in my video was detected by plotting some blue color. So we don't want small things to be detected in our video. So we will run a for loop over the contours that are being found, and we will draw the contours only if they are above a certain level. So this way we will not draw the small detection that is happening. So now inside the for loop we will write if cv2 dot contour area c is less than 5000, then continue, then skip the further processes. And now after that we will write x comma y comma w comma h equals cv2 dot bounding rect, and then in parentheses we will write c. It will help us to find the coordinates of the place in our video where the detection is happening, and also the height and width till the detection is happening. And now we will draw a rectangle from it. We know the x and we know the y, so we will just add them up to draw the rectangle. X plus w will be our horizontal line, and y plus h will be our vertical line. So we will draw it by cv2 dot rectangle, and then frame comma x comma y, it is the coordinate where the drawing of the rectangle will start, and then x plus w and comma y plus h, and then we will write the color of the rectangle that we want to draw. So this time I will set it as green 0 comma 255 comma 0, and then I will specify the thickness of the rectangle boundaries that I want. So I will set it as 2. In your case you can set it whatever you want. Now let's run it. As you were able to see, the places that were moved in the video were covered with a rectangle. So that's what we wanted. And now we want that if some detection happens, then play some sound to alert the people in the house. So there are many ways to play the sound, but in some cases the video is paused when the sound is played. So we will play the sound using Pygame. So we will first install Pygame. We will do it just by writing pip install Pygame. And now as I have already installed Pygame, it will show us like requirement satisfied, something like that. And now I will import Mixer from Pygame. And then we will initialize it by writing mixer.init. And then we will load the sound that we want to play. So in my case it is sound.wav. Well, the Pygame takes only WAV files, wave files. So like MP3 and other file types won't be played in Pygame. So now let's load it. Mixer.music.load, and then in parentheses we will write the name of the file, sound.wav. And now in the place where I have drawn the rectangle, I will put the code to play the music, because that code will only run if some detection happens in our screen. So we will write mixer.music.play. Now let's run it. Now as you can see, it is working perfectly fine. So thank you for watching this video. Hit like if you found this video helpful, and subscribe to get the latest update of my channel. Thank you.